Hey everybody, welcome to another episode of NASA in Silicon Valley Live. I'm your host, Abby Tabor, and if this is your first time joining us, NASA in Silicon Valley Live is a conversational show out of NASA's Ames Research Center, where we talk about all the nerdy NASA news you need to know. So I have here today our old friend Tiffany.
Hi, everyone. I am your co-host, Tiffany Blake. If you didn't know, we are live on Twitch, YouTube, Facebook, and Periscope. But if you want to participate in the chat and ask our guests questions, there's only one way you can do that, and that's at www.twitch.tv/NASA.
Yeah, and I know you're going to have a lot of questions because today we are talking about air taxis and the future of urban transport. And we have a couple of awesome guests here to tell us all about that. Hey, guys.
Hello.
Hey, Abby.
Why don't you tell everybody your name and what you do here?
Sure. Hey, everyone. I'm Shivanjali. I'm an aerospace research engineer, and I do research on new aircraft and how they enter our airspace.
Awesome.
Great. And I'm Joey. I'm a research aerospace engineer, and I look at new ways to manage air traffic.
Okay, a good team.
Oh. So, Abby, before we get into the show, how about we remind our audience about our really cool clock here?
Yeah, for sure. This is our moon countdown clock, where we are counting down the next 5 years to 2024, when we're planning to send humans to the moon as part of the Artemis program. So this clock is counting down the days, hours, minutes, and seconds to 2024, when the first woman and the next man will walk on the moon's south pole. Woo-hoo. So, exactly. Get excited for that. And if you want to learn more, you can go to nasa.gov/Artemis. But for now, let's get into the topic of the day, right?
Yeah.
Can you guys start off by telling us, how is NASA reimagining urban transportation?
Yeah, so there's this new concept that's come about. It's called urban air mobility. So you might hear us call it UAM.
Okay.
So what is like UAM, right? So one can imagine above them an air traffic management system that has everything from small delivery drones to passenger-carrying air taxis, flying safely and efficiently above urban centers or, almost above anywhere, almost every day. And that's that vision that we're really trying to enable, where we have new aircraft, new entrants, making our lives easier by providing functions that we all really need.
Okay, amazing.
Yeah.
So how did we get here? What led to this moment where we're working on this now?
Yeah, so industry has really been pushing things forward. There's, folks know, right, as we have automobiles, and as automobiles have been moving and developing, you have this new advent of electric cars, right?
Right.
So that same technology can now actually also be applied to aircraft.
Wow,
so we
okay.
have electric propulsion for aircraft. So just like you have this new clean and efficient way of providing transport for vehicles, this new clean electric transport can be applied for aircraft.
Okay.
So we have new automation also that's coming into play, so new control systems that are on board vehicles. And it's really that combination of those two things. Electric propulsion technology plus automation has really led us towards this new kind of mode of transportation that we're really excited about.
Okay, awesome. So these air taxis you've been describing, I think you came with an image of an example concept, right? Okay, let's bring that up and you can talk to us about what we're seeing.
Sure.
Oh, cool.
So this is a concept vehicle. This is what we call an electric vertical takeoff and landing vehicle. You can see it has 4 rotors, 2 on each side. So what's a rotor? A rotor are blades that spin to help generate lift, kind of like a helicopter.
Okay.
Right? So helicopter, you typically have one rotor above, and then you have a tail rotor behind. And so what these rotors do is they provide lift. This is just one configuration of a potential urban air mobility vehicle. There are many different configurations. You can also see here that that vehicle also has a wing. Right? So how would these vehicles kind of fly? You can imagine that they would take off vertically and then shift to forward flight, leveraging their wing to have efficient performance.
Okay. A cross
Interesting.
between a helicopter's takeoff and a plane flying forward.
Exactly.
All right, sweet.
We have a couple of questions here already. We have Big Bad Tom, who says, don't we already have air taxis, better known as a plane?
Good question.
That is a good question. So traditional commercial aircraft, current day aircraft that we all fly in today, those are for longer flights typically, right? So you might fly from San Francisco to LA or San Francisco to New York or wherever you are interested in flying. Those are over longer trips, so you're covering lots of miles.
Right.
And also those aircraft use fuel, so jet fuel. These new air taxis or urban air mobility vehicles are electric propulsion vehicles, so you're no longer relying on jet fuel. And in addition, they're typically flying shorter missions. So there's a kind of a wide range of their mission types, but you're typically flying shorter missions and you're using a different mode of fuel.
Right. And then within a city or a couple of cities, something.
And they're also smaller.
City limits,
Yeah.
Smaller.
Or
Normally-
between cities,
yeah.
right? So you would
Yeah.
normally book a flight from San Jose to San Francisco.
Right.
But this concept.
Though we
maybe-
all wish with the traffic.
And that's exactly what this is looking at. Yeah.
Right, right.
Taking us off the road.
Like, so Hovercat here says, will they be like large multicopter, battery powered? What kind of range are we talking about?
Yeah, so there's a whole host of different configurations. Some have 4 rotors, like we saw in that image. Some have 2. Some have many, and they also have some with wing configurations. They typically about 4 to 8 passenger carrying in terms of the size, and many of them are electrically powered. So yes, battery power is where many of them are going.
We're talking about passengers, but actually cargo could be one of the first things that really starts to test this concept out.
Okay.
Right?
Yeah.
Makes sense, yeah. So passenger vehicles, cargo delivery. Are there other applications that you guys see as really important?
So one of the major applications we can see coming forward is emergency services.
Okay,
So one can imagine if you have current day helicopters being used to provide ambulance support services, these vehicles could be flown in areas that might be dangerous or difficult to get to and provide those same emergency type services. So there's a whole host of applications.
Awesome. Great. So that's easy to see.
Yeah.
How we're going to use them, how that's going to be super helpful. There must be challenges for people like you to develop these systems. Are there a few that you would highlight?
Yeah, so I would actually take a phrase that's used by the FAA. So
That's the Federal Aviation Administration?
Right,
Okay.
right. So we are working very closely with them to see if we can make urban air mobility a reality. One of the phrases that they like to use is they like to focus on the aircraft, the airman or airwoman, and the airspace. So what does that mean? Well, these vehicles, they're new, right? So these aircraft have to be certified. There are going to be interesting challenges on how we certify these vehicles, as they have different performance characteristics. We mentioned that they're going to be battery powered or electric vehicles. That has implications on their certification.
Okay, certifying them as safe to fly, like they're
Exactly.
brand new, and we're going to declare them safe for the skies in our cities.
Right.
Okay, yeah.
And then if we talk about the airman or the airwoman part, or air person, that implies that we have to also think about what is the role of the pilot and how do they interface with potentially new controls, right? Like if they have different
Whole new
ways of
training.
flying, whole new training,
Yeah.
potentially a pool of pilots that may not have the same training that our current pilots today have. So how do they actually fly these vehicles? That's also a really important question that we have. And then the last piece, which I think is also really important, is how do we integrate these vehicles in our airspace?
Into their space.
Right. It's not just 1 or 2 of these vehicles that may be flying in the future. You can imagine hundreds or thousands of them. And if that's the case, how do we integrate them safely and efficiently into our air transportation system, into our national airspace?
Right.
And an interesting part of the research, actually, if you look at those 3 buckets, right, the aircraft and the airman or airwoman and the airspace, some of the things that are done in the airspace now for the current traffic may be better handled by one of those other buckets.
Oh,
And
okay.
some of the things that a pilot takes care of now maybe can be better handled by the airframe itself. So understanding where these things should get handled in this new way of travel is an important area of research as well.
Yeah, okay. Yeah.
We have a good question here from Space Walrus. He says, are we going to have air traffic lights? Is there going to be a direct path they follow, mannerisms, things like that can help with navigating?
Yeah, this is actually the exciting part. Shivanjali talked earlier about the advances in vehicles that are allowing us to get to this point in time, but actually the advances in airspace management are really important as well, and these 2 things are converging. So yeah, there actually will be stoplights. They'll be digital, right? They won't actually be floating and hovering up there. But
Red, yellow, green.
Yeah, and there would be a set of procedures and policies and rules that people that are operating in this airspace would need to follow. follow in order to have the whole thing still work safely and efficiently. So figuring all of that out is a big area of research, and we do collaborate with the FAA to figure out what is a good path forward.
Yeah. And you said this is about helping these new vehicles get into the national airspace, right? Can you define for everybody what that really means?
The National Airspace System is it's what enables us to have air traffic and air transport in the U.S. today. It's a collection of everything that makes that happen. So it's the runways you can think of, the air traffic control towers, the airports, the radars. It's actually the vehicles as well, and the people that take care of all these things and actually run them day to day. But it's also things you can't touch. It's things like rules and procedures and frequencies. All of that stuff together makes up the National Airspace System.
Okay.
So how do you introduce new things into that? You can see it's a delicate dance to make sure you don't harm what's working well now and enable these new ways of travel.
You guys are the choreographers of urban air mobility.
Ooh, I like that.
Is that your job title?
Can we change our job titles?
Yeah.
Good one.
But I don't think this is a question on the list, but I'm sure that people are asking themselves, why does NASA work on this? You guys have a good answer for that?
I'm sorry, I'll jump in.
Yeah,
but,
go for it.
The thing people forget is that first A in NASA stands for aeronautics. And we do a lot of aeronautics research. And even people that do remember that aeronautics is part of what we do, they may forget that air traffic management is actually a major part of aeronautics, is how do you actually allow these vehicles to get up in the air and fly around and do what they do.
Right.
And we have a pretty good history here at NASA Ames and within NASA as a whole of doing that kind of research. So it's really natural that this idea of this new airspace management concept kind of originated with us.
Yeah.
And I would say we're also been collaborating with the FAA for a number of years. So as our research has been developing, we've been collaborating with the FAA to transfer technologies and new research capabilities to really make our airspace much more efficient, our air traffic management, really improve efficiencies as much as we can.
Yeah, I know you guys work closely. And I know that our aeronautics research goes way, way back here at Ames. We at the center here, Ames Research Center, we started as an aeronautics lab, right? In 1939, December 20th, 1939, which makes tomorrow our birthday.
Yay! Happy birthday, Ames.
Happy birthday, Ames. It's our 80th anniversary tomorrow, so we're glad you could be here and help us celebrate.
Yeah.
So do you have any favorite fun facts about that air traffic management research that's so important that we do here?
Yeah. First of all, I was told there would be cake. So it's the main.
Sorry, Joey.
Okay. Anyway, so yeah, we have done a lot of research in air traffic management, and a lot of the tools are behind the scenes. They're things that people won't see every day.
I bet, yeah.
But they're the kind of things that save people 5 minutes here, 10 minutes there on your way to somewhere. Right? Everyone has landed at an airport and has kind of waited to get a gate, right? How do you optimize that and make people get to their gate faster? How do you let people route around bad weather quickly and efficiently and save 5 minutes and a smoother ride to get to where you're going? And these are time savings for us as passengers, but that translates also to money savings for the airlines, right? And these things add up, 5 minutes here, 10 minutes there, over the course of a year, across all the airlines.
Right.
These savings really add up, and these are the things that a lot of the things that we've originated research here at NASA Ames.
Awesome, yeah.
And I think some of these efficiencies have come from flying in the air. Some of them actually have come from trying to make the surface operations much more efficient. And so really, like Joey was saying, it's all about time, right? That's our most valuable commodity. And so how do we save our time? And that's where we develop algorithms, tools, work really closely with air traffic controllers to give them tools to make their jobs easier. And so that's something that we've been doing research on fundamentally for the last 30 years.
Oh, yeah. That's going back.
Yeah.
It's not just research, it's transferring it to the FAA to make them real.
Yep.
Right. They actually put it into use, right?
Yeah.
Right.
Yeah,
So
awesome.
tools in our air traffic control towers, almost every air traffic control tower today has some technology that we have worked on here at NASA.
That's so awesome. I don't think people know that.
We have a question here from Just Me and My Laptop. What part of the traffic or air traffic management do you see controlled autonomously?
I think if we think about how many of these operations there are going to be in the future, if people's minds race a little bit and you think about how many new flights there will be, the current system isn't set up to handle that many more flights that quickly. So actually a lot of the functions to enable these new entrants are going to need to be automated, as well as some of the processes on the existing side in order for them to know how to integrate and manage this new traffic as well. But we're not going to have enough controllers that can talk to all of these aircraft to do all of these things all the time like they do with the aircraft today.
Yeah.
So a lot of those functions are going to be automated, so there will be a lot of automation to enable this to happen.
Yeah, sweet. Yeah. Do you want to take any more right now?
Oh yeah, I mean there's plenty. The chat is really blowing up. People are very interested in this topic. There's some questions about, how do we, so Hobbs 555 says, how do we prevent midair collisions with air traffic?
Yeah.
With air taxis.
Yeah,
Excuse me.
so like Joey was mentioning, there's going to be new automation that's going to come on board the vehicle potentially, as well as tools for air traffic management services. So what are the intersection of tools that are on board the vehicle, as well as services that might be provided from potentially air traffic controllers or other entities? And that's kind of what we're investigating. And then where does automation help ensure that we reduce any issues in terms of safety impacts? So safety is kind of the number one goal. How do you ensure safe operations?
Yeah, that's great.
And the tools we develop, they really look at a few different layers, right, of how you make this happen. The air traffic management layer, that's usually a strategic look ahead. Like, how do we not put too many vehicles in one spot such that it's really hard for them to avoid each other?
Right,
so
the
it's
planning.
strategically, you kind of keep them apart through this ground automation and having them share what they're going to do with each other. But then more tactically, a lot of that onboard capability is going to be important to keep them separated.
Yeah, great. Yeah. So all these tools that you guys are talking about, a lot of that work is done at Ames here, but also in all other NASA centers across the country, right?
Yeah.
So you guys have a lot of partners.
Yeah, definitely.
Yeah.
So NASA Armstrong, NASA Langley, Glenn, almost all the NASA centers that are focused on aeronautics are contributing to making urban air mobility a reality. So this is pretty exciting.
Yeah. A big collaborative effort.
Yeah.
So when did all this begin for urban air mobility and what's going on today? What kind of work is happening now?
So one of the areas where this kind of first started in terms of NASA involvement is what we call the Grand Challenge.
Grand Challenge.
Yeah, it sounds kind of exciting,
Grand.
right? Yeah. So the Grand Challenge is an activity in which we are working collaboratively with the FAA as well as industry partners, both vehicle industry partners and airspace industry partners, to kind of develop an ecosystem. So we can really begin testing out some of these concepts. What does it mean to fly a vehicle? What kind of data do we need to collect to help with the certification process, understand the performance of these vehicles? And then also start understanding what does it mean, what kind of tools and technologies, what kind of software do we need to build to actually have some sort of air traffic management system for these vehicles as many of them start coming up and becoming a reality. So the Grand Challenge is a series of flight demonstrations and simulation activities where we really hope to explore all the safety cases as well as collect data to help us move the industry forward.
Yeah, makes sense. You get as many minds as possible thinking about it, predicting what you have to work out now, and doing the work.
Yeah, definitely. It's definitely a very collaborative effort.
Awesome. Great.
A legit Twitch channel asks, will there be miniature airports for places to pick up and drop off? That'd be cool.
Yeah. So some of the concepts that are coming up in terms of infrastructure, which is actually a really important concept, is a concept of vertiports or vertipads or skyports, skypads, however you wish to call it. But you can kind of imagine like a helicopter pad, right?
Yeah, okay.
These could be on the ground or on actually the top of a building, right? And so these could be locations where these aircraft could take off, because remember, they can take off vertically and land vertically. So they don't need a
Unlike a
runway.
plane,
They don't need a runway like a normal aircraft today. So that is what's going to allow operations in an urban center, right?
Yeah, cool. Is this going to mean the end of traditional flight, or is this really just complementary to everything we use today?
Yeah, it's definitely not an end to current day aviation.
Okay.
In fact, you can think of it as a complement to help you actually use current day aviation even more, right? So one can imagine that you might want to get from wherever you're located, a suburb, to your nearest airport. And normally we would have to sit in traffic, drive maybe half an hour, 40 minutes to get there.
Who knows? Yeah.
So depending on where you're located.
Yeah,
now, what if you can take one of these air taxis or air shuttles to get to your airport? Now it's actually much easier to use commercial aviation like we do today. So these are just another form of transportation to help us use current day aviation.
Yeah, I see.
Yeah.
And about air taxis or air shuttles, which you just kind of made a distinction there. Do you think that these are going to be taxis that I call up and I say, I personally want to go to my specific friend's house? Or is it going to be like a subway or a city bus that has a route?
So most likely, as this industry develops, initially it will probably be more like an air shuttle or an air metro, where you have a series of designated locations where you have pickups and drop-offs and at scheduled times.
Okay.
That's mostly to help us understand what's the feasibility
In the
of
beginning,
this,
yeah.
of this type of transportation.
makes
But
sense.
on-demand air mobility is something that industry as well as we are researching and investigating of how to enable it. So we're actually looking at both. How do we have a air metro or air shuttle as well as on-demand urban air mobility?
Okay.
Yeah.
Stay tuned.
Pretty cool, right?
Yeah.
Cool.
We have a question here from Space Walrus. What elevation will they be flying at? What if you're in the city? Do we weave through skyscrapers?
Yeah, good question. Good question.
What
So
should we picture here?
So since these vehicles have kind of a wide range of configurations, they have different cruising altitudes that they would fly at. You can expect, though, a range of typically from somewhere to like 1,000 to 4,000 feet is on average that typical range of these vehicles, of the urban air mobility vehicles that are a little bit larger than than some of the drones that have been flying below 400 feet. And then they are also kind of smaller than your traditional aircraft because they only have about 4 to 8 passengers typically.
Okay.
So that's the altitude they would be flying at.
Yeah.
In terms of weaving between skyscrapers, I think we're looking at procedures as well as ways for these aircraft to fly safely. And that includes safety of the passengers on board as well as the safety of the people on the ground.
Right, of course. Yeah.
I see a question here for the both of you. Seriously Gaming asks, what are Shivanjali and Joey's thoughts on noise pollution from these, and what are their thoughts on potential objects falling to Earth?
Yeah.
Is that a part of
Definitely want to avoid the objects falling to Earth. And in general, noise pollution speaks to a larger issue of kind of public acceptance of these kind of operations. So we can solve a lot of technological problems and make sure things stay safe and efficient in the airspace, but if the public's not ready to accept these kind of operations for whatever reason, whether it's environmental, including noise, or something else, then this won't ever take off, so to speak, right? So part of the research when we do our testing is actually making sure we're starting to ask some of those questions and collect some initial data on public acceptance so that we can feed some of those conversations to see what kind of barriers might be there to kind of that public acceptance question.
Yeah,
So
makes sense.
noise is an issue, and I think you'll see a lot of the manufacturers of these vehicles, designers of these vehicles, and of the airspace procedures are kind of cognizant of that. Like they want to be aware of trying to minimize the impact or acceptability of these operations. So it is something that is considered in the design of all the pieces of the system.
Right. Good to hear.
Yeah. What's another question we have here? Hobbies 555. Would there be weather restrictions on air taxis?
Yeah, so just like today in commercial aviation, today weather plays a big role in how aviation, goes on today.
Right.
And similarly, it will play a role for these new vehicles, for these urban air mobility vehicles. One of the things that we're trying to understand is when we perform tests as part of the grand challenge is understand what is your performance, when can you fly, at what gusts of winds, are there limitations on your performance? And those are some of the things that we're really trying to investigate so we can answer that question in a better fashion once we have data on how these vehicles actually perform under different wind levels as well as different types of precipitation.
Okay. So really specific stuff.
Yeah.
You're
That
not
you're
leaving anything
researching
to
and
chance.
testing for.
Yeah.
And really interesting, kind of related to that is, understanding the performance of the vehicle so that it knows what it can handle, what situations it can handle. But then actually on the weather side, actually doing the research to make sure that that information is available to those operators.
Okay,
Because the
right.
weather we use today for aviation is really focused around airports and the en-route environment, and there's some specialized stuff for helicopters in cities, but that all needs to scale up quite a bit in order to provide the right information to operators so that they can fly safely, given the performance characteristics of their vehicle.
Yeah.
So a lot of cities aren't outfitted for that level of granularity of weather.
Oh,
right?
okay.
So how do you get those weather services and weather requirements developed so that you can actually enable these operations safely? So that's a large area of research that we poke into, and we also try and encourage industry and universities and other folks to come along with us in that research.
Yeah, makes sense.
Yeah.
Kind of along those lines, that weather is actually very interesting in an urban center,
I was
right?
gonna
So,
ask, yeah.
So as you have wind flow between buildings, as you have kind of different types of eddies kind of round off of building surfaces, you have interesting effects that can occur. And so that's really important for us to have some knowledge about and understand, such that we can have safe performance of these vehicles.
Yeah.
So that's actually a really big part, what Joey was referring to.
Yeah, I can imagine. I felt that in cities, right?
Yeah, of course.
Walking between two skyscrapers and
Yeah.
the wind is just like gusting
Yeah.
by. Yeah. So good to know you're thinking about it already. Oh, let's see what other questions we got. Will we one day see a return of airships or zeppelins? Ghost of ET asks. Who knows?
Yeah, so airships, the dirigibles have been around for quite some time and have been used, obviously in the past, and now we see the Goodyear blimp once in a while, right?
Yeah, I saw it recently.
Yeah. So airships do have some purpose and are used for some use cases, but how they're going to be integrated in the airspace, it's a similar question, just like a lot of these new entrants. What's your performance like? What's your performance characteristics? Based on that, how do we integrate you safely into our airspace? Right. So those same types of questions apply regardless of what type of vehicle you may be.
Yeah. But the vehicles you guys are talking about are much, much smaller. 4 to 8 passengers.
Smaller and a little bit faster, right?
About drifting along to your destination.
Yeah, just a tad.
Trek Petra 1, do you have any idea how much energy it takes to vertically lift the passengers? He gave a number of 8 passengers, but just in general.
Yeah, so typically what is desired is you want to have vertical lift up above 50 feet, such that you are climbing at a rate of about 100 feet per minute. So the energy that's required obviously depends on the weight of that individual airframe, plus the number of passengers or cargo that you might have on board. So I would say it actually does vary depending on your configuration of your vehicle. But what is neat is the fact that there's been quite a bit of development in distributed electrical propulsion, which means you can use these electrically powered rotors, have them distributed across the airframe such that it's actually much easier to provide
lift
lift for aircraft. And that's a new technology.
Like we saw in that vehicle concept,
exactly.
right? It had the rotors along the wings.
Right.
Yeah.
Right.
I see.
Right.
Cool. And the airframe, when you guys say that means it's like the structure of the aircraft?
Correct.
Okay.
Just how that aircraft is configured. Does it have 2 rotors, 4 rotors? Does it have a wing?
I see.
What does it look like?
Yeah.
Yeah.
Makes sense. Okay, cool. We probably have time for a few more questions.
Yeah, we have a question here from Dact the Werewolf. What power densities would be required to make long-range, high-capacity flight possible using battery power?
Yeah, power's a big issue, isn't it?
Yeah. So the manner in which battery technology is developing is something that industry is really moving forward with. Things that they're concerned about is their charge and discharge rates, and then also how quickly can you recharge your actual battery on board so that you can fly another mission or go on another trip, right? And so there is quite a range of energy density that's required, again, depending on your configuration and depending on your mission profile.
Right.
Am I flying 50 miles or am I flying 40 miles, right? So depending on the mission you wish to achieve, you do see a kind of a range in terms of the battery or power requirements for that vehicle.
And just bring it back to the question of the vertiports, kind of designing the system and the power requirements. You may want your vertiports close to a substation that can supply the right amount of power to recharge you quickly. So all of these things are definitely interrelated, right?
Yeah, you sort of touched on this already, but maybe to sum it up for Fergus Diggums, can you comment about the possible infrastructure that might be needed for the shorter range trips? Will it use existing airports or a combination of existing and new? And you talked about rooftops, but how would you sum that up?
Yeah. I think that if we're talking about a new mode of transportation with new use cases, there's probably going to be new infrastructure needed, and that's when we talk about these vertiports and charging stations and all of these things that don't exist, as well as things like surveillance, as well as weather monitoring we talked about earlier.
Surveillance, like keeping an eye on the
surveillance,
vehicles,
like knowing where the vehicles are.
Yeah.
Right? Not so much how they get used, but just where the vehicles are. Right now, we have radars, and they can see all the big airplanes in the sky.
Just keep track of them all.
That infrastructure doesn't necessarily let us have full visibility into the area where these things might be flying. So surveillance, as well as, again, the recharging and the landing and the takeoffs, all of that's infrastructure that definitely has to be considered when designing the system.
And I would say infrastructure is actually a big part of this, right?
Of course.
And the FAA is, as well as NASA and as well as industry and other research institutions, they are looking to understand what are the infrastructure requirements. And there are sensor requirements, but then also things such as lighting requirements, right? What kind of procedures need to be developed for that type of infrastructure. So there's a whole host of information that would come along with the infrastructure that that will be needed for these vehicles to land or take off from locations near us, right? So there's lots of interesting research there.
Yeah. Research kind of leads the way to those answers.
Yeah.
Right.
Yeah.
Discovers the questions and then leads us to the answers. Yeah, that's interesting. Maybe just one more. And this question came in a while ago from Hobbs555, so maybe it's been answered. But I want to know, is this like flying cars? What's the question? Can we call these flying cars, or is that something else?
Well, so if you want to call them flying cars, you technically can. I mean, some of these vehicle configurations do have wheels, right, for landing.
Cool.
Some do, some don't, right? So if you have wheels, then you can actually do taxiing, I guess, technically, if you can call it a flying car. People do call them urban air mobility vehicles due to the fact they can perform a number of different functions and have slightly different operations than what we're used to today, right? So the terms you use can change, but essentially it's like an air taxi, a flying car, kind of whatever you wish to call it.
Yeah, and I think that the car implies a lot of freedom, right? And that's that on-demand mobility we were mentioning earlier.
Yeah.
So most of these initial vehicles are probably more like the Air Metro Shivanjali was mentioning earlier, right? They're kind of designated where they're going to go.
Yeah.
So if you wanted to call that a car, sure you could, but in general it's more like a subway or it's going where it's going to go, and it can help you get there quickly.
To start us off.
Yeah.
Okay, cool. All right, well, let's move on to our next topic so that we don't run out of time, but we're going to come back to more questions later. So I know that NASA has already done a bunch of research over several years that really helped lay the groundwork for this urban air mobility work that you're doing. So Joey, you were a big part of that. Can you tell us about the system you worked on?
Yeah, so for the past 5 years or so, we have been working on how do you manage small drones at low altitude at kind of a big scale. How do you have thousands of small drones flying over the state of California taking care of things?
Okay, yeah.
So again, that's the current air traffic management system was not designed to handle that kind of traffic. So how do we enable those use cases and those business cases to occur without overloading the current system and keeping everything as safe as possible? So that's what came about. Our research was called UTM, UAS Traffic Management. And again, UAS Traffic Management just means how do you manage drones? Right? How do you manage drones?
Yeah, okay.
So the UAS is the drone.
That's right.
That's
Yeah,
right.
UAS is
we love acronyms here.
I know.
That's everyone's favorite acronym within an acronym.
It is, yeah. We get bonus points for compounding them.
You do. Well done.
Right. But yeah, we were focused, again, on small drones. We're talking about 55 pounds and under.
Okay.
And we're talking about low altitude, typically 400 feet and under.
Yeah.
But again, you can
current.
accomplish a lot of things just in that airspace with these kind of vehicles. And it made us ask certain questions and develop certain systems and test certain things with partners and the FAA that lays the groundwork for some of the still open questions for urban air mobility that we have been talking about.
Yeah, that sounds familiar.
Yeah.
Kind of work you're doing. You mentioned lots of applications. What are some examples for small drones?
There are a lot. Usually you can actually classify them into some of the more interesting ones into the 3Ds, dirty, dangerous, and dull jobs.
Okay.
There's a lot of jobs you can do with these drones that can actually keep people safer that are doing them, right? Infrastructure inspection, for example, looking at a cell tower, taking pictures and making sure it's working correctly. People die climbing those towers every year, right? And other kind of power line inspection. These jobs aren't always the safest jobs, but you can make them safer by using drones,
Okay,
right?
perfect
And then
example.
things like there's agricultural applications as well, taking pictures of your field and doing analysis on that, as well as public safety things. Fire and police agencies are using these a lot more at a local level. Large companies are talking about delivering things to your doorstep. Again, all this can happen with drones under 55 pounds and under 400 feet. So there's a lot of things you can actually do with them.
Right, yeah, for sure.
And how do you let everyone do all those things simultaneously and keep the airspace safe?
Exactly.
That was kind of the research that we were looking at.
Yes, because that's always the key, right?
Yeah,
How can we do
safety
this
first.
Safely, yeah. What was your role exactly?
So I was the chief engineer for the project, so it was really about kind of coordinating a lot of the technical aspects of it. I did focus a lot on the software aspect of it. So we talked about automation earlier and the airspace management, how it's going to have to be automated in the future to handle all of this traffic. So how do you build a system that enables all this stuff to happen? It's cloud-based, and it leverages a lot of best practices in the software industry with our knowledge and expertise at NASA for air traffic management. Right? So how do you marry those two things? And that's really what we were looking at.
And Joey won't admit this, but he was the brains behind the UTM project, and I would say that Joey and his team most recently won the NASA Software of the Year award. So that's actually kind of a big deal. So we give Joey a shout out for that.
Thank you. Yeah, we have a lot of brains on the project, which is great, right?
Yes.
That's how you make it successful.
You need a lot of perspectives.
Having a lot of people with a lot of different backgrounds to come to that is how you kind of get to these innovative solutions, and NASA's a great place to kind of allow that to happen.
Yeah. Awesome. Congrats.
Thanks.
Yeah.
Thanks.
So, what are some specific abilities you gave the drones or the system? Like you want to keep them separate, right?
Oh,
what are
yeah.
some specific examples?
You know, we had sort of a clean sheet to begin thinking about how to get this done.
Yeah, really?
Again, it's a clean sheet with the understanding of how the airspace works and how the vehicles work, right? So with those bounds, what do we want the system to do? One of the key things is how do we help make sure the drones don't run into each other?
Right.
Yeah, for starters.
Can we build a system that helps them stay safely separated, to some degree? Also, how do we keep them separate from traditional aviation? How do we make sure they don't fly into other aircraft, right?
Yeah.
Can you build some system that helps with that process? One layer of this isn't going to be the end all and be all of all these answers, but how do we start this process of keeping the airspace safe? Also, how do we allow folks that are doing these operations and the vehicles that are doing these operations be identifiable, right? We don't want just rogue or unidentified objects flying around the airspace. People need to know what's there,
right?
To keep the airspace, again, safe. There's kind of a security aspect to that as well. And then how do you have some priority for important operations, right? So, for example, recently there was actually a drone that delivered a human kidney for transplant that was actually transplanted into a person successfully, right? So that was demonstrated one important use case for drones.
Oh, yeah.
How do we let that happen without being hindered by drones that are delivering hot dogs to people, right? We want to make sure the hot dog drones get out of the way, right, and let the kidney drone come through, right? So that's just one example. How do you, So these priority operations need to be thought of as important in the system as we design it out.
Yeah,
and there's a lot more
sense.
of the important class of operations you can think about, but the idea is how do we make sure that that can actually occur?
Right, that all of this can occur, right? You'll get your hot dogs.
You'll get it.
But after the kidney gets delivered.
30 seconds later. Right.
And I would actually add that services that Joey just laid out, they are extensible and applicable for any new entrant, right? So Joey was talking about how they were applied for drones. But if you can think about for these larger urban air mobility vehicles, for any new entrant, your Zeppelin, these same tenets can be applied. So it's actually a really great foundation for us to build off of and extend for new entrants into our national airspace.
Yeah, it's so clear how it supports the same things Shivanjali's working on and trying to make happen.
The key thing is, the current system, again, air traffic controllers don't want to be controlling a 40-pound drone at 200 feet, right? They're not, they have enough to do with the big aircraft, and they don't want to hire 10,000 more operators to watch, all of these drones.
Every single drone.
Yeah, so again, this is the automation of the airspace and allowing these new entrants, and again, a lot of these things will translate over to this air taxi, urban air mobility world, finding out how much of that transfers over, how much of it has to change a little bit, but we have a foundation to start with.
Totally, yeah.
So that kind of answers Johnny CZ25's question here. Management will be autonomous, and yes, it will be autonomous.
It will have autonomous aspects, right? It doesn't mean you just push a button and the airspace is completely free to go. And the autonomous nature of it will increase over time, right? When you get started, you only have so many operations, and you might have a good amount of human supervision, but then as things scale out, how much of that can be automated, and making sure you do it, again, in a safe way.
Yeah.
It's more of like a continuum, right? So it's there's going to be pieces of it that are automated, some functions, and then how does that continuum grow as we move
over
forward
time?
in time? Yeah.
Makes sense.
Yeah.
Building upon it.
Right, exactly.
Yeah. So the drone traffic management system, what does it look like or feel like for a user, a pilot? Like if I want to fly my drone, what am I going to see?
Yeah, in the future, hopefully it would be very transparent. It shouldn't be a big burden to actually use the system. So there's actually be a layer between you and the airspace, and it would be kind of a service provider to get into the airspace, almost like a cell service provider, right?
Okay.
If you want to make phone calls, you have a cell service provider, and you can talk to other cell service providers cleanly. So you would have one of those providers that gets you access to the airspace, right? You would tell them what you want to do, maybe your intent, I want to fly from here to here, and I want to do it about this time. The idea is that these service providers share that information amongst each other. They do what's necessary to keep the airspace safe and deconflicted, and messages flowing that need to flow. And you, as a pilot, just take care of your mission, right? You just fly your operation. How much of that operation is automated and not automated, that depends in the future how far you go. But a pilot would be in charge of that operation and would do it cleanly and receive information back from these service providers about any changes in the airspace or things you need to know.
Right, like there's a storm coming up,
Exactly.
or there's an emergency operation. Or something.
That's right.
Yeah.
That kidney's coming through.
Right.
Yeah, exactly.
Get out of the way. Yeah.
Yeah.
Were
Yeah.
you
No,
gonna
and
add something?
No, I was just going to add that I think there's the whole host of different types of operations. It kind of lends itself to setting up different missions, right? And then I'd also add that the tools and the technologies and the integration with the partners that was built up under UTM, I think, is a great model. They interface with a whole host of industry partners along with the FAA, and that same model of collaborative innovation is what we're aiming for.
Yeah, that makes sense. And I wanted to go back to earlier. Somebody asked about like traffic lights or something. I forget what the question was. But you were saying there would be digital traffic lights,
Right.
not physical things up in the sky. But you've told me that we can think of the drone traffic management as like rules of the road that we
Right.
know when driving, right? Can
Yeah.
you talk about that?
We think about driving today. The folks that are driving, in general, you hope and expect that they know the rules of the road, right? They know what a red light means.
Right.
They know what to do when you both come to a stop sign at the same time. They know how fast you can go on the freeway and how to change lanes. Those kind of things don't exist for drone traffic, right? So what are those procedures? What are those rules? Who has the right of way in certain scenarios? And how do you share that information and make sure that everyone's aware of the same rule set and those sorts of
Right.
things? So that is a lot of the research we do as well. So that's really the drone traffic management system. It's defining those rules of the roads, the procedures, making sure everyone's checked out on all those things to enable all these operations to happen.
Yeah. That's a good
And
comparison.
when you have on your phone, it tells you when there's a traffic jam ahead, right?
Yeah.
So that's the next level of services, right? And that would be
Right.
part of the ecosystem as well. Oh, there is weather ahead, or
Yes.
there is a lot of drones over here, so maybe you should go over there, right? Sharing data so that you can make those decisions.
Yeah. Awesome.
Yeah.
That's really clear. Cool.
Oh, we have a question here from Trindane. Will these drones have an option for multitasking? For example, the drone could be delivering a kidney and also acting as a traffic camera en route. So will they have like different
I think the person waiting for the kidney would hope maybe it's focused on the kidney. Right?
and not doing the
But in general, it's all about the vehicle capabilities.
Right.
What did they design the vehicle to do? And the idea with our research with traffic management and all those sorts of things, how do we make sure we don't cut off any of those use cases? How do we make sure we enable folks to do the things they need and want to do in the airspace safely? So yes, and we have looked at drones being repurposed en route, right? You may be doing regular traffic surveillance, but then maybe there's a search and rescue thing that has to happen, and that drone could be repurposed in flight and take off and do something. So this idea of repurposing is definitely out there.
Yeah, and I would say for whether it's single task or repurposing or multitasks, what you need is a secure communication and navigation platform, right? So you have to be able to communicate to that vehicle, that drone, or that UAM, and be able to have that communication be secure. And that's, I think, as you have multiple tasks, that still is the foundation, is how do you have safe and efficient operations, right?
Yeah. Cool. So this year, you guys actually had a big milestone year, right?
Yeah.
Tell us about what went down.
Right. I mean, we've been doing this since 2014, researching this drone traffic management system, and we've been kind of building up in complexity of the kind of cases that you can handle. So when we got to this summer, we actually executed a flight test to demonstrate the most mature version of the system we have, and we did that in an urban environment. So we flew in downtown Reno, and we flew in Corpus Christi, Texas, with the help of the FAA test sites at those areas. And many, many partners doing that with us, right? And showing how the system would work in an urban environment. And finding out where the limits are, where the gaps are, and where it works really well. That's what we did this summer, and that was a really exciting time for us.
That's awesome.
Yeah.
You guys got video of that, didn't you?
Oh, yeah, we probably have some.
Can you tell us about it if we can bring
Sure.
it?
So, you're looking at Reno here. You're looking at a couple of drones taken off from the top of a building, and you can see they're flying near the casinos, and they're coming really close to each other. There's actually more space than you can tell from the ground here. And the key thing is that the two pilots for those vehicles know what the other one is doing because they've been sharing information. You can see one holding up here while another one passes by. Again, that's the rules of the road stuff we were talking about.
Right.
So testing all those concepts, and here you're seeing kind of a mission control center with folks from NASA as well as the Nevada test site working together to execute these activities.
Sweet. Interesting. So you were not the only one there, were you, Joey? you guys,
Yeah.
both of you.
Yeah.
I had the chance to go out and observe the UTM tests both in Reno and Texas, and I would say seeing the drones flying in that urban environment really makes it tangible, right?
Right,
This
I
is
bet.
a reality that's coming fairly soon, and to see how it's a combination of software, they leverage cloud services, plus the drone technology, plus the interplay of the folks on the ground, you really see what Joey was referring to as earlier as kind of the national airspace, kind of in a miniature version running in these field trials, which is great to see. And it really lends itself to help us understand what are still some of the major questions that we have to address. So all the data that's collected from these demonstrations is really, I think, very valuable.
Oh, yeah, no doubt. What was your experience like, Tiffany?
Well, so
I seem to
I'm
remember.
not an engineer or anything like that. So I was going to cover and help them amplify, the research that they're doing for the public. But I mean, I would say Reno was cold, and then Texas was very, very hot. But I would say, it was really a great experience to see the team kind of just. I feel like every test day was different. They learned something one day and they applied it the next day. And even when there were challenges, to see them all kind of come together, come up with a plan, fix it the next day was really great to see. And to have covered this project for 3-4 years now, it's kind of great to see,
See it come together?
Yeah, this accomplishment with them. It was really cool.
That's awesome.
Yeah.
So what would you say you learned in the end from these tests in downtown Reno and
I mean, it sounds kind of silly to say out loud, but it is really important to know that we learned that the system works.
It works.
Right? It can actually do the things we thought it should be able to do, right? It helps drones stay separate. Again, it's not the only layer of doing that, but it's a key layer of doing that. You can make sure you have access for priority operations. You can actually identify the drones in the airspace digitally and in other ways. So all of those pieces were executed in that airspace. And the other key thing is finding out more about what it takes to fly in that environment, right? Like what kind of things makes this hard, right? Let's go there and fly that. And it's not just flying one drone, right? A lot of folks can demonstrate something with one drone, and a lot of folks have done that with a lot of use cases. But bringing a full system out with many stakeholders, trying to collaboratively manage this airspace and execute missions is really important to do, and finding out where more work needs to be done and where things look like they're solved, right? And that's what these flight tests do for us.
Right, perfect.
Yeah.
And so what's next for the drone traffic management project?
So a lot of this, we've been continually handing off to the FAA. We talk about a partnership there, but it really is a tight partnership. We meet with them often, probably more often than they would like, right? We're talking with them quite often to make sure we understand what the FAA is thinking about where this is going, to make sure that what our research is tracking with that, and maybe leading it a little bit if we can. But they're going to be executing a pilot program as well, a second part of a previous pilot program. And we want to help them in that execution. And really that's about taking the technologies that we've been developing with the FAA and our industry partners and making them real in the airspace. So it's an important step in that direction. So we're gonna keep going that way.
All right, excellent. Great.
We have a question here from Resonator Games. Is there any fundamental concept that those in the private or commercial sector testing of the drone should be paying attention to?
There are so many pieces to this, right? So a lot of folks are specialized in a certain area. It might be on the platform itself, building, a detect and avoid sensor. How do you actually see things in the airspace and get out of their way? And I think that continuing to push all of those lanes is important. I think understanding the ecosystem as a whole is also really important. I think folks that do work on important sensors and important platforms, it's important for them to also understand the ecosystem in which those drones will operate. So just trying to keep pace and understand where the research is heading and where the FAA has signaled things are going. Just trying to stay abreast of all that stuff is really important.
Makes sense.
Yeah. Here's a comment on the drone traffic management system. Maybe you can respond. Twisted Metals asks, the pilot will be watching a movie just like now 95% of the time. So a drone pilot will be watching on screen? Will they?
I don't know. I would love to watch movies 95% of the time. I'm not sure.
Or 95% of drone pilots, I understand.
Okay.
Are they watching their flight on screen?
Oh, I see. Are they physically watching the aircraft, or are they watching some representation of their operation on a screen?
I guess that's the question.
Yeah, I think it's more the latter, right? Again, because we're trying to build a system so that these vehicles can go beyond visual line of sight of the operator, the pilot.
Oh, yes, of course.
Right? So they're not going to be able to just watch
it
the
in the
drone
sky,
now,
right? Right.
And that's how you enable all these business cases. You can't have someone watching the drone if you're going to go deliver that thing,
Yeah.
5 miles away.
Right.
You can't have someone or a line of someone's watching that. So how do you build a system that allows that? So yeah, there would be some representation of the operation occurring that the person that's in charge of that operation would have access to.
Yeah.
And it might be as simple as a moving map with some alerts that are coming onto it, right? Something like you'd see on your, for your regular driving, right? Something that's letting you know where you're going. Mm-hmm. Or it could be more advanced, right? It could be a 3D view, it could be a first-person view. It really depends on the mission and the environment you're flying in and what the future rules actually are to do that. Mm-hmm. So I guess yes.
Yeah, I would add, regardless of whether it's a drone pilot or a pilot on board one of these new types of vehicles, there's going to be different ways of interacting with the vehicle and controlling the vehicle. Mm-hmm. Just as automation increases and there's changes in how those vehicles fly, I think there's going to be some changes in that traditional pilot flight deck or cockpit relationship.
Yes.
And how you interface with that is going to change, and that's also another interesting area of research. All the way from human-computer interface logic that goes behind that, as well as what button do I push to land or take off, or is there an easy fly button, right? So there's all kinds of new ways to engage with aircraft, whether it's a drone or some of these new vehicles. And I think that's a really interesting area.
Yeah.
And I think one of the key things we're seeing a lot of research on from industry as well as the NASA side is how do these pilots maybe control more than one of these, right? Does it have to be a one-to-one relationship between one pilot and one active operation?
Yeah.
Or can you
That's
expand that further, right?
Yeah.
Can you actually have 3 people controlling 8 vehicles? Or can it be one controlling 2? Like, what are the limits of that, and what tools need to exist in order to make sure that, again, happens very safely?
Mm-hmm. Yeah,
for
sure.
We have a question here from Tamo101. Is there any cooperation with autonomous car research? I expect there would be similar challenges and opportunities with communication and control.
So I think the same principles of autonomous car, autonomous vehicle, self-driving cars, however you wish to call it, some of those same principles are, I think, important in aviation as well. So what can I understand what my environment is presenting to me, right? So do I have some awareness of what my environment is? For airplanes, that would involve, or aircraft and drones, it would involve weather, right? Knowing how strong your communication signal is to your base operations. All of those same types of questions about communication, safe communication, reliable communication, understanding of the environment around you, being able to react appropriately to the environment around you, knowing the rules of the road that Joey kind of referenced, whether you're actually on the road or flying in the air. Those are all same principles that can be applied.
Yeah, makes sense. Cool. I want to jump back to another topic that I want to make sure we don't miss.
Of course.
One of the coolest things I recently learned about the urban air mobility research is the simulation work that you guys do.
Yeah.
Can you tell us about that?
Yeah, sure. So, I think for all our Twitch fans out there, you guys might have Microsoft Flight Simulator, have used that. So just like you could emulate flying a Cessna or a Piper or even like a 747, we have advanced flight simulators here at Ames. There are kind of a combination of flight simulators. Some are fixed, meaning they don't move, and some move and actually allow you to feel all the forces that you would experience like you were flying in real life.
Amazing.
So we have lots of different kinds of simulators. And it's not just we have the fact that we have those simulators. It's that we have, or we're developing performance models for these new types of vehicles, so we can understand how they actually fly.
Right. They don't exist yet, so you have to invent the, the model of it.
Right. Exactly. It's to take some concept vehicles, understand how these vehicles would fly, what would their performance be, and then how would they actually fly in an emulated world in our airspace, and go through some of those same questions we've all been talking about.
Yeah.
How do I interact with my controls? Do I have a joystick like I would for a helicopter, like a cyclic?
Right.
Or do I have something else?
Right.
And what is that mode of interaction? Those are questions that we can also think about for these simulators.
Yeah.
Along with how do I interface with some new traffic management systems specifically for my vehicles, building off the work that Joey's been doing.
Yeah.
So there's all kinds of different things we can investigate with these simulators.
Right. Testing everything and how it comes together. together, right?
Yeah, exactly.
Yeah.
Exactly.
And
Like, what does this look like?
Yeah, right.
That's
And
so
we're going to
cool.
see what this looks
Yeah.
like in a sense, because you brought a video with
Yes.
us, with you, right? Let's
Yes.
see that simulation video and tell us what we're seeing.
Sure.
There. This is going to be.
So this is a video from one of our fixed base flight simulators, so a flight simulator that does not move. This is from one of our researchers, Mike Fury, and his simulator here, you can see that it shows a vehicle taking off vertically, and now it's moving forward in flight. And what's actually really interesting is some of these vehicles, as they move forward in flight, have this transition period, because you have to transition from vertical takeoff to forward flight. And helicopters, that kind of occurs instantaneously. But for these vehicles, you're going to have this transition period. And that's interesting to kind of understand. And now you can see the vehicle flying in urban center. In this case, it's a model of San Francisco. In our simulators, we can model almost any type of urban environment or any landscape that we wish to understand, or understand the procedures of flying. How would I land? How would I come in for my approach? These are some of the things that we can explore. So you can see this vehicle now coming in for its approach and its landing. And this is an interesting question. As you come in for your approach and your landing, you can see that vehicle kind of pitch up a little bit.
Right,
So
right.
how does that feel?
Right.
So if Joey and I were sitting in the back with our coffees in hand, would that coffee spill, or kind of how would we
You're
feel?
going to warn me first?
Yeah. So understanding that passenger experience is actually a really big part of some of the work that these simulators can do. So it's not quite this simulator, but we have another motion simulator that allows us to understand what is the passenger experience, what are the forces
What does it
you
feel
experience.
like?
Yeah, what does it feel like?
Right. I'm glad to hear
That's
that.
so cool.
I got sick on a whale watch this year, so I would like you to find out if I'm going to get queasy
Are you
on an air
signing up?
taxi.
Are you signing up? Or?
I'm going to let you figure
Okay,
it out
okay.
first for a while. Then I'll
Noted.
come sign up for a test. So these simulators, this for me was one of the coolest things I'd heard about. Do you have a favorite aspect of this research, or what's a really cool thing you want to share?
Yeah, so I'd say the number of questions that this research is kind of highlighting is really interesting. And the fact that it's this new era of aviation, this new mode of transportation is very exciting. So as this technology kind of develops and these new vehicle configurations come to life and we're starting to explore them, I think the really interesting thing is that this is a area of work that's going to continue. So all those folks that are interested in understanding or maybe even participating in this area, they have a chance to really be part of it. So people out there have a chance to be part of this new era of transportation. They can actually be involved, which I think is really neat.
Right.
Yeah.
This is by no means finished and settled, right? We still need help.
Exactly.
Yeah. Awesome. What about you, Joey?
What I'm looking forward to, or what I'm excited about?
yeah, what are you excited about?
Just taking a step back and looking at it from the outside, we are getting a little closer to being Jetsons world, right? This is almost like the Jetsons.
Age
We're
of
talking
the
about flying
Jetsons.
cars before.
Yeah.
We're still a few steps away from that, but we're getting there. Right? We're gonna hopefully have some more operations in the urban environment than we had before.
Right.
They're gonna happen safely. They're gonna get us closer to exactly where we want to go. It's really neat to see.
That's totally cool.
Yeah.
Yeah.
I know, right?
All right. Well, we've got a bunch of questions piling up.
We
Should
do.
we take some more?
Yeah. So eventually you were speaking about like the passenger experience and things like that. Legit Twitch channel has a question. Will people be required to wear parachutes? What kind of safety measures would we expect in oxygen masks, life jackets, things like that?
Yeah, no, I think that's a great question, and it raises the fact that as these vehicles are getting certified, there is that aspect of ensuring safe operations, and in the case of off-nominal events, ensuring that those folks on board have the appropriate mechanisms to ensure safety of life. Right? So just like we have the safety briefing that we all love to sit in when we go fly on commercial aircraft, there has to be something most likely similar for passenger carrying vehicles, even if they're urban air mobility vehicles. So safety is the number one concern for us, for the FAA, and for industry that's developing these vehicles. So there will most likely be something similar.
Yeah.
We just don't know quite what yet.
Yeah.
Yeah. Awesome. Johnny CZ25. Trying to pronounce these names. It's a struggle. Will it have aircraft cameras with special software to create a landing point? I know that you have worked on landing mechanisms.
There's a lot in that question.
I thought
There's
there
a lot
might
in
be.
that
So
question. But it's a
Take a
good one
second.
because it speaks to the number of ways you can accomplish things, right? So yeah, even you look at the small drones, they do have cameras of different types that help identify if a landing location is safe to land or not. Because you can plan ahead of time, I'm going to land in this open field, right? And I'm going to go there and I'm going to land there and everything's good. But you get there and there's a car there or people are having a picnic, right?
Right.
Do you have a system on board that can help you identify that and then go to an alternate location? So some visual technology is used to do that. Some of that has been developed at NASA Langley, for example, to do those sorts of things. And in general, when they're planning their operations, there would be some visualization probably of where they would like to go and how they would like to get there. So you could put a point on a screen, and then that could be translated into a flight plan, and that can be communicated to the system. All these things are things that are possible, and we've seen examples of already.
Yeah, neat. Okay, so you're all over that, working on that. Yeah.
We have a question here. Would be good for you, Joy. Resonator Game says, if you could snap your fingers and solve one aspect of industrial drone flight, what would it be?
Good question.
Just like that. If you could if you can solve the detect and avoid problem for all vehicles and all classes with a snap of a finger, that would do a lot, right? So that's
solve a lot.
the last layer of safety, right? How do you make sure that I see that thing that's coming at me and it's very close and I get out of its way?
So that means one drone being able to see another one coming and move.
Each drone could avoid the things it needs to avoid, whether they're static things on the ground.
Okay.
Maybe yesterday there wasn't a crane there, and today there is a crane there, right? And that's not on my maps.
Right.
How do I detect that? As well as other things flying in the air, whether it's a traditional Cessna with a real pilot on board that can't see your little drone, or maybe doesn't have the same maneuverability as an urban air mobility vehicle. How do these vehicles detect those problems and then avoid them? Right? If you could solve that problem, you get a long way towards a lot of the safety questions that need to be answered.
Yeah.
And there's a lot of ways to do that, and there's a lot of folks working on that, and there's some very good solutions toward it. But if it could be universally solved, that would be awesome.
Yeah, sweet. How about this one from Hovercat? Will the flight controllers and software firmware be open source? Is that something to think about?
Yeah, so that's an interesting question. For some of these vehicles, the manufacturers that are developing some of these vehicles have a whole host of configurations, and some of them are working with the traditional flight management computers or flight management systems that you have in commercial aircraft today, and some are new. Depending on the safety cases as well as the secure communication piece that's required, they might not be quite open source, but just like we have simulators today that help us understand the performance as well as the controls for those vehicles. I'm sure that something similar will be developed so that folks out there who want to try them out or can want to fly them in their own simulator will be able to do so. But as the industry is developing their tools, they're pulling from existing tools for flight controls today as well as developing their own. So it's kind of a mixed bag right now. Yeah.
Okay, neat.
In general, for the small drones, we're looking at in general, everything should be performance-based. How can you prove you can stay within the bounds of a certain performance envelope?
Okay.
I know I can control my vehicle under all these conditions, and I can show you how I do that. Now, that may mean you use an open source pieces, or everything's open source, or not. I can't say that if there was a single open source solution for a piece of that, and it was proven to perform in a certain way, then that would be very valuable.
Yeah.
But I don't think it'll be a requirement that everyone uses an open source particular element.
Okay.
Yeah.
I see. Another question here, but you made me think of it. You mentioned the word security. So, Legit Twitch channel asks, could drones be subject to hackers? Will there be security measures in place to repel unwanted or harmful signals?
So the answer to the first question is yes, definitely. I mean, any piece of IT technology, right, can be
Subject
potentially
to hackers.
hacked, right, if it's not built correctly. So the answer is yes. And again, it's part of not necessarily getting to, you want to be as secure as possible at all layers. But in general, we know that's not likely to happen. So how do you build enough layers in such that as you layer them all on top of each other, that overall the whole thing stays secure, right? It's kind of a Swiss cheese approach they call it. If you layer the Swiss cheese in certain ways, you cover up all the holes and you can't see through it.
Yeah.
Right?
Okay,
So,
makes sense. Good visual.
Yeah, so in terms of cybersecurity, I think that's what you want to look at with these drones, so that even if a given drone was hacked, let's say, that
Right.
it can't cause damage to the further system or to folks on the ground. Does it have other safety mechanisms to make sure that no harm can really come from that? So there is a lot of work in cybersecurity related to not just the drones themselves, but the traffic management system as a
Right.
whole. that if that was hacked, that would be bad as well. So, right. So how do you build all these layers in?
Yeah. So-
I think security has to be on the vehicle itself, the communication protocols between the vehicles and their operators. So there's, like Joey was saying, multiple layers of security are really required. So anything that's learned from the sphere of drones can be obviously applied to other types of vehicles as well. So it's a question that's, I think, applicable for all vehicles.
Yeah. All right, good.
And in general,
Once again.
research-wise, we like to consider security a first-class citizen in the research process, right? It's not
Yeah.
something you tack on at the end. It's something you make sure you're thinking about and engaging industry with and the FAA with and cybersecurity professionals with as you build up the system. Because you don't want to come up again with a great technological solution that easily hacked and the whole thing falls apart.
Right.
So you want to make sure it's robust from the beginning.
Yeah, exactly. Consider that all along the way.
Yep.
Yeah.
How third? I don't know. I just totally butchered your name, so I'm so sorry. How do you deal with increased radio traffic?
Yeah, so there's probably a couple pieces of that. One is like overuse of a given channel, right? There's just too many people talking on a channel.
Stop talking.
Right? And then there's also just kind of a certain band being overused. For example, command and control we talked about earlier. And that's one of the things we looked at in our flight tests in Reno and Corpus Christi was for these small drones, command and control, different radio frequencies we use. When do they get saturated? When do you have problems with them? Turns out if you fly near an apartment building, there's a lot of people with Wi-Fi routers. And if you're conflicting with that, you may have trouble communicating with your drone. These are really known issues, but actually kind of taking a look at it in a real urban environment was important.
Yeah.
And I would kind of add to that, you would want to understand what kind of concept would not saturate like a radio frequency too much. So you want to ensure that any concept that's being developed, Joey has mentioned that air traffic controllers may not want to be talking to every one of those drones, every one of those UAM vehicles. So that's part of the concept. So understanding, hey, how is this actually going to work? That's a really important part of ensuring that we don't saturate certain pieces that we know have limits to them. And that includes spectrum as well as frequency. So that goes back to the foundational research. What's the concept of operations?
Yeah. A lot of what you've been saying today is plan for that challenge.
Right.
Figure out what it is today and plan around it. Yeah. Here's an urban air mobility question from Legit Twitch channel again. Could this research eventually lead to people being able to own and operate their own air taxi? Do you think that's coming?
Yeah, I think there's going to be lots of different use cases and modes of flying. I think there's going to be cases where some folks may be able to own their own vehicles. Most likely it'll be a service like we use today. We've seen a big rise in service-based technology, right? So we'll all use, whether it's vehicles or food delivery services, right? So we've just seen more of that coming along. So most likely urban air mobility will be accessible as a service, but who knows, right? We can all really be the Jetsons. So Joey's vision of the future may come to life.
We're close.
We're close. We're close.
It's funny, like you mentioned the Jetsons, and yet, like when I told my mom we were talking about drones on the show today, she said, "Oh, like the Bruce Willis movie, like Fifth Element." And I was like, "Yeah, Mom, but way safer." Check the show out.
That is a bit of an insane future vision there. Yeah, this is a little more
way safer, normal. Not exactly like that. We have a question from Hovercats. What's your reasonable tip for a flying taxi driver?
Good practical information here today.
That's a great question. So I would say I go back to like the foundations. What is the national airspace? You got to know your rules of the road. You have to know your procedures. You have to know your safety and your certification aspects. If you know those, right, you can fly safely and get to where you want to go from point A to point B. But you have to have those foundations. Just you get like a driver's license before you operate.
Right.
You've got to have some sort of certification before you fly.
Right.
Yeah, for sure.
Yeah.
The old joke is what Seabiscuit in the third. That's my tip, right? So that's what.
You guys actually understood that question differently from where I was taking it. I was going to say 10%, 15%, like I tip my hairdresser. What's the tip?
That's a good one. I didn't think about it that way.
Right?
Either,
Because already,
but you're right. What would be a reasonable tip?
In a ride share, I don't know how much
interesting.
to tip. It's awkward.
But I must say, I want all of the advice that Shivantli gave. I want my driver to heed to that.
Well read up on all of that, please. Right? All right. Well, let's take a few more.
Yeah. We have Joseph Urban here says, will cargo air taxis be allowed to fly autonomously before passenger air taxis?
So maybe Joey and I will tag team this one, but I'll start. I think as autonomous applications come forth, certification, I go back to that because that's also part of this. How do you certify an autonomous system? Right, so that's a question that we have, and we're doing research to explore what that means. Generally, folks do believe, flying cargo may come before flying passengers, right? Just as a natural progression. But there are still lots of questions, even if you're a cargo autonomous flight.
Yeah, no, I totally agree. I think the cargo stuff is where we'll learn a lot, probably before the passenger stuff. But that's a somewhat separate question from how autonomous they're allowed to be in the airspace. How do they prove that they can still stay safe? You have the benefit of not having people on board, but you still can't have it doing bad things in the airspace or to anything on the ground.
Right.
So there's a lot of questions to answer, but I would guess, a lot of the things in cargo would happen prior to passenger activity.
Yeah, makes sense.
Yeah.
I think it goes back to what you said, Joey. It's a performance-based solution, right? So let's understand the performance of these vehicles,
Right.
and then how do we integrate them into our national airspace?
Yeah.
And those are still the questions that need to be resolved. So.
Yeah, always the same. Cool. Here's a cool idea from Space TV Net. They're asking, will augmented reality be used to display virtual roads in the sky? Could you do that?
Yeah, you definitely can.
Yeah.
We sort of have. We've seen it, and we've done a little bit here as well.
Awesome.
And the roads, it can be as simple as just, cylinders that you have to stay within.
Okay.
But again, when we're getting to these beyond visual line of sight things, and there's not necessarily a pilot on board for the small drones, obviously it would be hard to carry a pilot.
Yes.
It is more about how much can this be an autonomous operation, right? But visualizing your plan, visualizing the airspace structure, visualizing different aspects of your operation, augmented reality could be a key part of that. We actually tested some of that in Texas as well. We had folks with the goggles on, looking at the data from the air traffic side as well as the management side of that, and interacting with the aircraft in the air in terms of zooming in on them and seeing information that's available digitally. So you could see folks managing in a dense environment, maybe just being aware of everything that's going on, could have a lot of value. So some work is actually going on in that direction already.
That's awesome. That seems like a perfect use for that kind of technology.
Yeah,
Yeah.
it
That
does.
seems really helpful. Yeah.
We have a question here from Mega Man BXR. Do you think drones will play a bigger part in crime prevention, i.e. monitor the streets overhead in real time, etc.?
We already know that a lot of public safety organizations are looking at using drones more and more.
Fire departments.
Yeah, and if you think
Yeah.
about safety and security, one of the big things we've seen a lot of success on, you can just see it in the news, is search and rescue operations. Cities are able to buy these drones that can actually see heat on the ground, so at night they can be flying and see a lost child in a field, right? And then send folks to that location. Obviously you can do a lot of good things with drones, right? One of the other use cases is a fire department wanting to send a drone out ahead of the truck because it can get there faster to survey the scene before the people get there to fight the fire. That's another use case that people envision. Again, the airspace has to be ready for that, right? Because
Right.
we go back to the hot dog drones. They have to get out of the way of that fire drone coming through. Right. So
Yeah, absolutely.
without a unified a system to share that information, you can't really make that happen cleanly.
Right.
But yeah, there's a lot of interest in from police and fire and other agencies to use these for the things that they already do.
I think we already see a lot of emergency response applications.
Right.
I think with the recent fires here in California, we saw some of that here as well. I think the tools provided a great insight for some of those, for example, firefighters to fight the fires that were blazing, and then also for like volcanic eruptions. There's been been a whole host of other use cases for surveying and providing emergency response. But like Joey was saying, we need the rules of the road there,
Right.
and how these aircraft are going to operate, or these drones are going to operate, to really enable them to do their missions. So.
Right.
Yeah, and we think about public safety, keeping the public safe, but these drones can actually keep the first responders safe as well,
Right.
So they
Right.
can send a drone to the top top of a roof to see bad guys or whatever it might be, or someone that might help, without actually putting people in harm's way first, right?
Yeah.
So public safety does go both ways. So there's a lot of really good uses for this in the police and fire realm.
Right.
And in some cases, like in the testing, like I know in Corpus Christi, we had the fire department there with their drone as well, so working closely with the
did
research
you?
and helping.
Exactly.
Yeah,
Yeah, we had
great.
the fire department as well. Corpus Christi Police and Fire were great partners.
Awesome.
There, organized by the FAA test site in Texas. And again, they had drones already in their inventory. They
Oh,
were
they
already
did.
using them for missions. So
They were ready.
Wow.
They were participating with us in the flight testing, right?
Yeah.
Giving us some feedback on the concept as a whole, and us understanding how they already use their drones and make sure that the traffic management system and the concept still accommodates what they would like to do.
Yeah.
It's really important to get that feedback early and
Totally.
often. So yeah, we're already seeing these agencies do that, and the police were interested in using it obviously to identify drones, right? Like if in the future there's more of these in the air, they want to know that they're supposed to be there, or they're allowed to be there, or they're doing
Yeah.
something good and not bad. So police who have an interest in knowing that the airspace is safe around the public as well.
Of course.
Yeah.
Yeah, yeah. I have a question here that's making me picture the Fifth Element scenario. Tachirian Dono asks, with drones, you can have many, many small missions starting and ending constantly. So how do you ensure efficient use of airspace with an unknown number of vehicles entering the airspace at any time? It sounds like a lot of unknowns.
It is.
And a lot of potential drones.
Yeah, and I think you do want to take a stepped approach, right? A gradual approach. You know, we don't have to build the system right now to handle 20,000 operations a minute in a city block, right? You don't have to have that system ready today.
Yep.
But how can you start to enable 30, 40, 50 operations over a city at once, right? And then you'll start to see where there are some issues with them sharing the airspace or information so that they can all accomplish what they want to do. And then slowly you can build up those densities. And that's kind of been our approach in the research.
Yeah.
And we see that approach being adopted as well in industry, right? As they come up with standards around this based on our research to help inform the use of the airspace, they're not looking to solve the problem 20 years from now. They want to enable more and more operations today and tomorrow.
Right.
And it is that scaled approach. So we'll come up with those solutions. We want to make sure that the architecture and the concept will support them in the future. Don't box off any solutions. And it's going to work. It's going to work.
And I would even up-level that complexity, right? So you can have drones operating below 400 feet.
Yeah.
Then above that, you could have these electric urban air mobility vehicles flying across urban centers. And then above that, your commercial air traffic. So how do you have interoperability across all of those layers
Right.
and that same density of operations? And that's
Right.
actually where the real fun research questions kind of lie, where some of our work comes into play is how do you have that air traffic management system to support all of these new entrants and all this density of operations we expect in the future.
Right.
I'd raise you one up level, right? We can go 60,000 feet
Yeah.
plus, right? So
Oh,
we have
really?
the traditional air traffic, and then you have folks that want to fly over 60,000 feet. Maybe
Drones?
It's with, no, not maybe autonomous vehicles, maybe not. But how do they share that airspace up there with autonomous vehicles? How do they get up there first in the first place
Right.
in an efficient way?
With such a busy.
Exactly. So all
Yeah,
these things have to interoperate and you know work well together.
Yeah.
Have to level up, Hunter.
Yeah.
Oh.
I left space for you. You could have gone one more.
I could have gone one more. Do you want to take maybe one more question over there? Do you have
Sure.
a good one to throw out?
Well, we have a question here, like, what was the biggest barrier for you personally getting hired? But we always get questions like this, and people want to know, like, how did you get started at NASA? And, you know,
Yeah.
Yeah.
like,
Yeah.
what's your background?
Exactly.
Yeah, sure. So I'll start first,
Sure,
Joey.
yeah.
So I'm an aerospace engineer. So that's what I studied in school. That's what I got my bachelor's and my master's in. And to be honest, I've always been passionate about aircraft and flight, and specifically flight controls, and that's how I got started. But I think there's a whole host of opportunities and avenues. I don't think you have to study aerospace engineering, nor necessarily even just aero. So there's a whole different set of fields and discipline that make our research a reality. Right? We have people who are psychologists, engineers, analysts, people who work with data. So you can really do anything. I think it's all about the passion. If you're interested in kind of seeing how we can push the bounds to bring in all of these new entrants, bring in innovation into air traffic management, I think there's so many ways you could come in and play a role here.
Yeah.
Definitely. And just to illustrate that with this drone traffic management project that we had, we had folks that were aero engineers, very important to understanding the system and how the vehicles work and all of those sorts of things. I'm a computer engineer, so I'm not an aero engineer by training. So that's important in kind of building out the systems. We had a lot of computer scientists, computer engineers helping with this as well. And then you do get systems engineers and physicists and other folks that really matter in doing these. Human factors people, right, that understand. Again, Shivanjali was talking earlier about what do these new control systems look like? How do people interact with them? It's a completely new system we're talking about. So we don't really know how the human needs to interact with it.
How it's going to impact the human.
Exactly. And what
public.
makes their job easier or harder, right? So all of those kind of folks are really important in building out a system like UTM, and that's what we had on our team.
Yeah. It sounds like it makes sense, right? Like you've talked about so many aspects of this work, different facets, different layers. You kept saying different layers of the system. You need so many different perspectives on that. So that's awesome. So that's good news for people out there.
Yeah.
It really does take a team. I think you have a team with a whole wide range of disciplines that really allows some of this technology to come to light. So.
Right. Sounds like it.
It's a great place to solve hard problems. Right? That's what aeronautics really offers. Right? And I think it's what it brings a lot of people. That's what brought me in. Right? It's a good place to solve really hard problems that make an impact.
Fascinating. Awesome.
Yeah.
Well, this has been awesome. Thank you guys for joining us
Thank
today.
you.
We have just about run out of time, but thank you for being here. And thank you to everybody who joined us in the chat on Twitch. We'll be back in the new year, so follow NASA on social media to hear about upcoming shows. And to see past episodes of this show, you can check out nasa.gov/Ames/NASA in Silicon Valley Live. All right. Thanks for watching, and we'll see you next time.